Hello and welcome everyone to our weekly session titled Latest in Bitcoin Tech. And as every week, this week as well, we'll go through the Bitcoin Optech newsletter. And this week, we'll be covering newsletter number 294, published on 20th of March 2024. I'll just go through the preface of the letter first so that we get to know what is in store for us. This week's newsletter announces a project to create a BIP324 proxy for clients and summarizes a discussion about a proposed BTC Lisp language. Also included are our regular sections describing recent changes to clients and services, announcing new releases and release candidates, and summarizing notable changes to popular Bitcoin infrastructure software. Okay. The first section, as always, is the news section, and the first news article is pertaining BIP 324 and how it can, or how encryption that BIP 324 enables and authentication can become accessible to light clients as well. So I'll read through it. The title says BIP 324 proxy for light clients. Sebastian Falbisona posted to Delving Bitcoin to announce a TCP proxy for translating between the version 1, that's V1 Bitcoin P2P protocol, and the V2 protocol defined in BIP 324. This is especially intended to allow lightweight client wallets written for V1 to take advantage of V2's traffic encryption. Light clients typically only announce transactions belonging to their own wallets, so anyone capable of eavesdropping on an unencrypted V1 connection can reasonably conclude that a transaction sent by a light client belonged to someone using the origin IP address. When V2 encryption is used, only the full nodes receiving the transaction will be able to definitively identify it as originating from the light client's IP address, assuming none of the light client connections is subject to a man-in-the-middle attack, which is possible to detect in some cases and which later upgrades may automatically defend against. Falbisona's initial work pulls together BIP 324 functions written in Python for Bitcoin Core's testing suite, which results in a proxy that is terribly slow and vulnerable to side channel attacks and not recommended to use it for anything but tests right now. However, he is working on rewriting the proxy in Rust and may also make some or all of its functions available as a library for light clients or other software that wants to natively support the V2 Bitcoin P2P protocol. That's what the text says. Okay, so other than status for, I'd like to would somebody want to take a shot at what BIP 324 is, what it does, or something you've heard about it, even if it's loosely, broadly on the surface level?
Yep, I can give it a shot.
Sure.
So BIP 324 is an encryption layer for the P2P network in Bitcoin. And what I mean by encryption layer is that all the messages that are transported between full nodes and all the communication that happens on Bitcoin, whether it's transactions, blocks, authentication, and identification messages, are unencrypted. So anybody eavesdropping can identify that it is a Bitcoin transaction or somebody's running a full node. And BIP 324 encrypts those messages as a standard for all full nodes. I'll take a pause here in case.
Sure. Status, would you like to affirm it or add something, or was he exactly on point?
Yeah, he was exactly on point.
Thanks.
Yeah, that's my understanding as well. Because like currently the mechanism through which Bitcoin nodes interacted with each other on the network was in an unauthenticated manner and in plain text. So any information that was being gossiped among peers on the network was easily detectable to anybody who wanted to eavesdrop on it, and thereby leaking confidential information, which also included the IP addresses and even the physical location of the node that is sharing information. What a BIP 324 does is that it encrypts the information that is being shared or transmitted among nodes on the Bitcoin peer-to-peer network, right? And soon this will become the default mechanism. I think currently the default mechanism is V1 version 1, which is unencrypted mechanism of sharing information. And you have the provision to shift to V2. And I think with Bitcoin Core 26.0, V2 will become the default mechanism through which information would be shared among the nodes on the Bitcoin network. So we'll just go through the definition of what V2 protocol is. So version 2 or V2 P2P transport is a proposal to allow Bitcoin nodes to communicate with each other over encrypted connections. Some other changes to the communication protocol are also suggested, such as allowing frequently used protocol commands to be aliased to shorten byte sequences to reduce bandwidth. This proposal replaces the earlier BIP151 proposal. So, like by now, we know that what BIP 324 does is that it enables sharing of information between peers on the Bitcoin network in an encrypted manner. But there are other mechanisms to do that as well, right? Like for instance, Tor can do it, and also I2P can do it. What would be the reason why BIP24 is an upgrade or is preferred over just routing messages over the Tor network or I2P network? What is it that BIP324 does that Tor and I2P cannot, or don't do as good as BIP324 does? Anyone?
I think I know about Tor that it uses onion routed mechanism, which can be cumbersome in terms of bandwidth and storage. So it's much more cost effective to do it by encrypting the message itself and not relying on onion routing. About I2P, I'm not sure.
Yeah, I mean that's what I've heard and read as well. That I mean the latency in Tor and I2P can be very cumbersome at time, and with 324, the information is transmitted relatively quickly, and I mean the information is transmitted in the form of binary, and that is why it is quicker as compared to Tor and I2P. But that is not like the major purpose why BIP 324 was proposed. The major purpose is encryption. This is like something surplus or supplementary that you get. Okay, so Sebastian Falbisona posted to Delving Bitcoin to announce a TCP proxy for translating between the version 1 V1 Bitcoin P2P protocol and the V2 protocol defined in BIP 324. This is especially intended to allow light client wallets written for V1 to take advantage of V2's traffic encryption. So currently what happens, the latest information I have is that when two nodes are trying to interact with each other, the first scenario can be both of them are interacting using the version 1, right? Node A is also initiating messages using version 1, and node B is receiving those messages and reciprocating using version 1. So both the nodes are communicating over the version 1 protocol that is in plain text. The second mechanism could be both of them are using V2. Okay, so the node A also uses V2 and node B also uses V2. So now the data that is being exchanged between the nodes is completely encrypted. But there is also a possibility that there is a node that is only compatible to and that only understands V1, and it is interacting with a node that wants to use V2. Like the node B is privacy conscious, or they don't want to share information in the form of plain text. How do these two nodes interact with each other then? If node 1 has V1 enabled and the node 2 has V2 enabled, obviously the node that is using V2 can go back to V1. But if they don't want to, if they want to stick to V1, if they don't want to share information in the form of plain text, there is no mechanism for these two nodes to communicate with each other. If one node insists on V1 and the other insists on V2, there is no mechanism for these two to communicate with each other. Sebastian Falbisona has come up with a mechanism that will enable nodes that are using V1 protocol to communicate with nodes that are using V2 protocol. Currently, there are no light clients that implement V2 protocol to the best of my knowledge. So what this does is that this hinders communication between light clients and those full nodes that want to communicate over a V2 network. So what Sebastian suggests is that a proxy server will be set up. Okay, now a light client, instead of establishing a connection directly with a remote node, okay, like an outbound peer, the light client will establish a connection with that proxy server. Light client will initiate messages in version 1 to that proxy server. That proxy server will convert the V1 message into V2 message and then share it further to the remote node that understands V2. And when the remote node that understands V2 reciprocates, that information will also go to the proxy server. Proxy server will convert it into V1 and then give it to the light client. That is how it happens. I just have see, broadly this is how it will happen. Okay, so there's a light client. Okay, the light client will not directly establish a connection with the remote node. Okay, the remote node is a full node that uses V2 protocol to share information. So the light client generally establishes a connection directly with the remote node. Okay, but here what we're doing is we've set up a proxy server. You can see the block in the middle, that's the proxy server. So the light client will initiate connections with the proxy server. Okay, and the light client will send all the messages or information in V1 format to the proxy server. The proxy server will do its own magic, convert that V1 information into V2 information, encrypt it, and then send that encrypted information to the remote node. This is how it will happen. So this is the local socket. Okay, here this is like the proxy server 1.2.1.3.2.4. That's the proxy server. This is the proxy server that the light client establishes a connection with. Okay, and then what happens is that V1 to V2. Okay, if the information is going from left to right at the bottom, as you can see, okay, then V1 to V2 is converted. So the message is taken in V1 format, okay, and then it is encrypted into V2 format, and then it is sent further to the remote node. And if the information is flowing from right to left, that is from the remote node to the light client, then the information comes in V2 format, it is decrypted, and then it is encoded into V1 format, and then the light client gets the message. So this is nothing like how we have, like translators. For instance, if two people are trying to communicate with each other and they don't understand any common language, they will find a person who understands that common language. So person A will speak in his native language, the translator will translate it into person B's native language, okay, and then the person B will reply in his native language, and the translator who understands both the languages will translate it into person A's language. So this is what is being done. The light client understands V1, the remote node understands V2. We've set up a proxy server. The light client will establish a connection with the proxy server, not directly with the remote node. And the remote node will convert V1 messages to V2 and give it to the proxy server will convert the remote V1 into V2 and give it to the remote node. And when the remote node reciprocates, he will convert V2 into V1 and give it to the light client. So this is how it happens. And I mean, you'll get a better explanation. A PDF that I shared a couple of days ago, whoever would be interested should go through that PDF. That's much more neat and tidy. See, this is how it happens. This is a light client. It is establishing a V1 connection with this proxy server. The proxy server converts V1 into V2 and gives it to the remote node, and the other way around will also happen. This is like more detailed. Here the V2 is getting decrypted and then it gets encoded into V1 and goes to the light client. On the bottom, the proxy server receives the V1 message and then it encrypts it and sends it to the remote node. So that is broadly what is happening here. And this is to facilitate communication between light clients and nodes that support V2, because very soon with Bitcoin Core 27.0 release, V2 protocol will become default. By default, nodes will interact with each other in an encrypted manner, and then there might be compatibility issues with light clients, because currently no light clients fully implement. Maybe some are testing, but I don't know of any popular light client that fully implements V2 protocol. So this is the proxy server that will facilitate communication between light clients that don't support V2 and help them communicate with nodes that support V2. Okay. Now, basically, I hope like broadly the concept is clear. What this proposal is trying to do, and what this proxy server is trying to do, and how it is enabling how it's facilitating communication between light clients and remote nodes that talk over the V2 protocol.
I just had one question that so this is taking into account the risk of the proxy node communication being leaked, right? So that can still technically be eavesdropped.
I mean, this proxy server, I think it is on your local system. It is on your local system. I don't think it is connected with the Bitcoin network. So the moment information enters the Bitcoin network, it is encrypted. Otherwise, it doesn't make any sense. If the information enters the Bitcoin network and then you encrypt it, it doesn't make any sense. So it's your local server that establishes a connection with a proxy. Okay, this proxy, I believe, is in your local computer, and then it converts it and sends it to the network.
Makes sense.
Okay. So yeah, and the purpose of BIP 324 is to prevent man-in-the-middle attacks. I've mentioned it in the notes as well. Okay, it's you cannot bypass active nodes. Okay, like an active node that is actually if somebody's actually running a node on the network, they will definitely get information about you. Okay, so you cannot hide any or conceal any information from them. This attack mitigates MITM passive attacks. Okay, so if somebody is not running a node, your ISP service provider or the government or an authoritarian who's not willing to participate in the Bitcoin network, they are just there to eavesdrop and intercept information and get location about your censor some transactions or force your ISP provider to share your location or censor your transaction. That basically mitigates those attacks. So these are passive attacks. Passive attacks is basically an attacker is just trying to manipulate traffic. He's not contributing or participating to the network. Okay. An active attack is when an attacker is actually running.
Did you see this? Did you get this from somewhere that MITM attacks has two kind of types, active and passive? Because as far as I know, MITM attacks are always implied active. There are two kinds of
Sure, please go ahead.
Yeah, no, from what I've thought, there are two kinds of attacks. You can actively attack or you can passively attack. If you're actively attack, you have to be a man in the middle between the two connections. So that's kind of like an active attack. You have to run a full node and you have to be a man in the middle. But if it's like a passive attack, you're not actually being a man in the middle of two nodes. You're just passively eavesdropping. So I always thought MITM attacks are always active, but maybe it's just a terminology thing.
I think it's more or less just a terminology thing. I did read it. I'll share the source with you, but yeah, I think it's more about a terminology thing, because even I've mentioned here what are MITM attacks. MITM attacks are performed by secretly connecting to both the peers. So my definition here mentions like an active case because here you are connecting to both the peers and relaying information between them. So both parties think they are speaking with each other directly when the communication is being actually controlled by the attacker. So yes, MITM attacks, the definition does mention or imply that it's an active attack. I will also go back to my resources and verify. Maybe I have mistaken, and if not, then I'll share the source with you for sure.
Yeah.
Okay. Yeah, that's yeah.
Something else I'm still trying to wrap my head around. So we have a light client and we have a proxy and we have the entire the remote nodes, the full nodes, the entire P2P network. So I was wondering where it's preferred to be V2, which link it's preferred to be V2. Is it the proxy to the entire P2P network? Is that preferred to be V2, or is it the light client to the proxy part which is preferred to be V2?
Light client to proxy will be V1. See here, this is the light client, this is the proxy. Okay, and you can see light client to proxy is V1. Okay, so the proxy will receive the messages in V1 form and then it will convert it into V2. That's what the diagram says, right? Light client to proxy is P2P V1. So the proxy will get V1. The proxy will convert it into V2, and then once it's converted into V2, then it will send the information further to the remote nodes. So light client to proxy is V1, proxy to remote nodes are V2.
Okay, because we're running
True, and I think he's shared a code snippet here as well as to how he'll do it. So depending on whether it's the local socket and the remote socket, your local socket is your light client and your remote socket is the full node. So depending on who the initiator of the message is, if the message is being initiated by the local socket, then the proxy server will receive it in the form of V1. It will convert it into V2 and give it to the remote node. So it'll probably destructure or something this local socket object, take the message type and the payload, okay, and then it'll pass it into this function that will convert it into V2. This is the recipient, the remote socket. This is the message type and the payload, and then it gets encrypted and then it is sent to this recipient remote socket. And if the initiator is remote socket, then this conditional statement gets executed. So from the remote socket, you take the message type and the payload, and then you convert it into V1 using passing them as an argument. This is the recipient local socket, the message type and the payload that are passed as an argument to this message, and then it sends to the the light client. So the light client is interacting with the proxy in V1, and the proxy is interacting with the remote node in V2.
Okay, makes sense. Yes, it does. Oh, and light clients, normally how many full nodes do they connect to? Do you have any idea?
I think 8. I'm not very sure about it, but I mean, do you have anything with you that makes you believe that there's a difference, that they have less number of full nodes that they connect to?
No, it's just a question. I was just thinking of what are popular Bitcoin core light client examples and normally how many nodes they connect to.
And I mean, we've discussed on various occasions that a full node connects with 8. I don't know if the light client has some different number not sure about it. You can look into it later, and I or you or whoever would want to delve into this can share in the thread. But I personally am not aware of the actual number.
Yeah, no worries. I guess it depends on whoever is implementing it. I was just curious.
Okay, right. So the light line need not comply with like like if a full node is establishing outbound connections, what number is 8? Is it like a consensus rule? You have to establish 8 outbound connections, or it's absolutely up to you. That is the maximum limit. You can go below that as well.
No, it's tweakable. Like you can change it. Like it's just a default thing which is recommended in the network to have 8.
Okay. And we discussed 8 plus 8, 16, right? What were the other 8? You can go up to 16 or manually connect to 8 and by default 8. Is there something like that? You're not audible, Satisfy, if you are speaking. No, you're not audible, Satisfy. If some issue with your audio, it seems, so you can fix that and get back. In the meantime, any questions pertaining this particular news article, or should we move forward?
I'm good with moving forward.
Cool. Let's move forward. So the next news article is overview of BTC Lisp, and I think we covered this as much as we should and as much as falls under the purview of this session last time when we discussed that Anthony Towns is working on a variant of Lisp language. Okay, currently Bitcoin scripts are executed using a stack-based language. Okay, where data is put on stacks, and then there are opcodes that manipulate data on the stack. Okay, and the functionality of the programming language is limited. And we discussed how Anthony Towns believes that a Lisp variant should replace Bitcoin's scripting language, just like it has done in the Chia Lisp programming language. And he basically has shared the progress that he has made, and he's gone a little more into detail and the more intricacies of how this programming language that he's working on, that he calls BTC Lisp, how it's shaping up and how it can do a lot of things that Bitcoin's current scripting language cannot do, and how it can facilitate looping without the possibility of somebody inducing an infinite loop, and how we can reduce the number of opcodes that we use in Bitcoin's scripting language, which would need to more concise and compact code. So like this is a very long article. He shares a lot of information, so whoever is like really interested in going into it can go into it. And also I think in the comment section and even in the Optech podcast, the person who's working on Simplicity, like Simplicity is another proposal. It's a programming language that is being proposed and being worked on since quite some time as an alternative to Bitcoin scripting language. So there's Simplicity and now there's BTC Lisp. These are like two prominent languages that developers are working on as a substitute or as an alternate to Bitcoin's current scripting language. Okay, so like I just go through briefly like how a Lisp language is different from Bitcoin's current scripting language. Okay, like we did this last week, so I'll just skim through it and then move forward. Okay, so like basically in order to save information in your computer's memory, a list of information, the two most popular data structures are arrays, which all of us are aware of. This is how an array looks like. Okay, and in arrays elements have to be in sequential order of the memory location. Okay, so like for instance here, this is an array of 4 elements. Okay, the first element is 1000 bytes. Now let's assume this integer eats up 4 bits. Okay, so from 1000 bits you go to 1004, you go to 1008, you go to 1012. Okay, now these elements have to be in sequential order. You cannot have the first element at 1000 and the second at 1008 and the third at 1004 and the fourth at 2000. You can't do that. So the elements of array should be in sequential memory location. They should be in consecutive memory location. The second mechanism to store a list of information in a computer's memory is referred to as linked lists. Okay, and the difference between an array and a linked list is that in an array, the elements in a linked list, the elements of a linked list can be randomly stored anywhere in the memory of your computer. Okay, so the first element is stored at memory address location address 5000, the second is at 2000, the third is at 1000, the fourth is at 1500. Okay, so you can see in the array the elements are sequential, 1000, then after that 1004, after that 1008, after that 1012. But in a linked list, that is not a prerequisite or a condition at all. The first can be at 5000, the second at 2000, the third at 1000, the fourth at 1500. Okay, now how do we find if we've reached the first element? How do we go to the second element? In array, I know that the first element is an integer. It's an array of integers. An integer takes, let's say, 4 bits. So I know that the second element is 100% going to be at 1004. But in a linked list, I don't know. It's not necessary that the next element will be at 5004 and then 5008. So how do I find where the second element is? So a list contains of a data is like contains of two parts, the data and a link, which cumulatively are known as a node. Okay, so the first part, which is the data, is the actual data itself, the element. Okay, and the second is a link that connects you to the next element. So when you go to the first element, it's number 1, address is 5000. Okay, now that will also tell you the address of the next element, 2000. So if you want to search for the second element, you go to memory location 2000, then you find the second element. The second element will tell you the address of the third element, that's 1000, you go to the third one. The third will tell you the address of the fourth element, 1500, you go to the fourth one. And then if you find null, then that is the final element in the linked list. And the first element is referred to as a head. Okay, you can invoke this head to find the address of the first element. So that's broadly the difference between an array and a linked list. So like BTC Lisp, which is a variant of Lisp programming language, which is like Lisp programming language was created in 1958. Okay, and its multiple variants are being used at multiple places, and there are multiple cryptocurrencies as well currently that are implementing different variations of Lisp, and one variation or a custom made Lisp variation for Bitcoin is also being considered, which some people believe might overcome some limitations that Bitcoin's current scripting language has. So I just had some like code snippets, which if anybody wants, like I've shared the notes in the comment section, would want to go through. So this is how data manipulation happens. I'll just go through one of them. Okay, so like if this code basically implies that you take 5, you take 4, and then you add all of them. So this is data 5 and 4, and this is the operator, like how we have in Bitcoin scripting language. There's data and there are operators. You use an operator of add. Okay, so let's say 5 is on the top of the stack, 4 is on the penultimate stack. Okay, so opcode will take the top 2 elements on the stack and add them. So this is exactly what's happening here. Okay, and here data and opcodes both are stored in cells which are known as consoles or consecutive cells. So this piece of code basically means take 5 and take 4 and add both of them and give 9. This is how data manipulation happens in Lisp, which is list structure programming or list structure processing. This is how subtraction happens, multiplication, division, remainder, and like in current scripting language, we use conditional statements for paying to the script or paying to the script hash. This is how control flow statements look in Lisp. Okay, we check for equality. We check for equality for in a P2P transaction, whether the hash of the public key equates with the hash that is being supplied. So like this is how some basic functions that Bitcoin scripting language performs using stacks can be done in Lisp using lists. Yeah, that is all I had to share about the second programming language. Broadly, Anthony Towns is working on a variant of Lisp programming language, which he's calling, or the community is calling, as BTC Lisp, which the people who are working, or the developers who are working on it, believe is an upgrade or is more flexible and adds more functionality to Bitcoin as compared to Bitcoin's current scripting language. And then another one that is being worked on is Simplicity. We currently have Bitcoin scripts, and then Simplicity and BTC Lisp are 2 programming languages that are being developed. So anything to share, any questions, any insights about this news article?
So I didn't follow why it is superior or better compared to stack-based language. Is there any specific reason it is recommended over it?
Some of them. One is that it allows looping, which Bitcoin's current programming language that executes stacks Bitcoin script, the Bitcoin stacking language, it does not allow, as you all know. But this allows looping, and at the same time, what is being claimed is that, I mean, there's a maximum amount of data that can be contained in a script. So you cannot induce infinite loops. Once the data surpasses the maximum amount of data that can be incorporated in the script will fail. So there is not a possibility of inducing infinite loops. And also at the same time, it enables looping, and the number of opcodes that you would use, like to perform operations in Bitcoin's current scripting language, you can bring down the number of opcodes in BTC Lisp. So the less number of opcodes, the less code you have to maintain, because every opcode that you execute, you have to write code to invoke that opcode and to manipulate data. So the lesser the number of opcodes you have, the easier and more concise the code base becomes. And there are various other reasons that are listed in this like mammoth article for whoever would want to go into the lead up of your day if you're interested. But yeah, these are two that I could pick up.
Right. Thanks.
Yeah.
So how does any idea how does it do away with the need of maintaining multiple opcodes?
I mean, one opcode can do multiple things.
Okay.
It's like that, yeah.
Okay.
So
Thanks.
you invoke the same opcode, and that same opcode can look at the data, and depending on what data it has, it can perform different operations. Like
Right.
how, I mean, speaking in a very naive manner, how we have overloaded constructors. Like, we can invoke one constructor and it can do different things depending on what data you're passing to it.
Right. Right. It's interesting. Have you heard of Chia anywhere else? This is the first time I'm hearing of. I mean, the last session we heard of it, but outside of Lisp, I don't think Chia.
Not me, man. There are so many
Right.
cryptocurrencies coming out every week. It's not possible to
But I
keep
think this is the
track.
first time that at least I have seen the implementation of the idea that cryptocurrencies outside of Bitcoin are a good experiment ground and they can bring innovation to Bitcoin.
Yeah, again, depends on which school of thought you belong to. Like this proposal
Right.
has also received a lot of polarized opinions on X and on Nostr.
Hmm.
Okay, all right. We'll move forward if nothing else to ask or share in the news section. We had just two news articles. The next section is changes to services and client software. The first is BitGo adds RBF support. In a recent blog, BitGo announced support for fee bumping using replace by fee in their wallet and API. This is pretty straightforward. Okay, so BitGo has a wallet. In that wallet, up till now, they were not giving a replace by fee support. Now they have added support for RBF in their wallet, and they also have an API which other wallet manufacturers can incorporate into their wallets. So both their own wallet and the API that they provide has now added support for fee bumping. And I believe everybody knows what fee bumping is. And if somebody doesn't, fee bumping is as the name suggests, like you you have already broadcasted a transaction, for instance, but you believe the fee is too low for that transaction to get included in the block. So you use the inputs, the same inputs that you used in that transaction, which is languishing in the mempool, in another transaction, and you bump the fee. And Bitcoin, like the Bitcoin miners will get incentivized to use the latter transaction that you broadcasted because it has a higher fee. That is what replace by fee is. So yeah, BitGo has added support for RBF in their wallet and also their API. The next one is, yep, someone wants to speak.
No, I was just adding a comment that it's interesting that BitGo has worked on Miniscript integration before it implemented RBF because RBF seems like at least a simple feature and useful to. I mean, Sparrow has it, right? So I think BitGo as a custodian, as a wallet for companies and services, I find it interesting that they implemented RBF now.
True. Yeah. Yeah, I think we even had a BitDev session, right, regarding mini scripts and descriptors
Yeah.
and music as well, both
Yeah.
with Saravanan. One was
Right.
online, one was in person.
I think the reason might be that BitGo is not a retail software. It's only for companies. So I don't know if companies might not necessarily need RBF, and probably that's why they did not feel the need to introduce it.
Yeah, true, maybe. I mean, it all depends on like what your target community is. Like a feature might be very, very trivial or essential for the retail, but if it's not for your target community, maybe you would not want to implement that feature. Cool. All right. So next one is Phoenix Wallet version 2.2.0 released. With this release, Phoenix can now support slices while making LN payments using the Acquiescence protocol. See newsletter number 262. Additionally, Phoenix improved the swap-in feature privacy and fees by using their swap root protocol. Okay, so Phoenix Wallet is one of the most popular clients of Eclair implementation. As you all know, Lightning Network has multiple implementations. One of them is Eclair, and Phoenix Wallet is one of the most popular clients that are built on top of Eclair. what they have done is that they have this protocol known as a swap root. Okay, and it is not something that they have incorporated right now. It has been there since before, but now they have upgraded it. They have added some features that make it more cost efficient, that make it cheap to use it, and that also enhances privacy. Okay, so firstly, what is splicing? Okay, because the swap root protocol, it is basically splicing, right? It does what splices do, or basically it splices the transaction. Okay, so first we'll have to know what splicing is. So broadly, the act of transferring funds from an on-chain output into a payment channel is splicing. Okay, so if you don't splice, and you want to increase the liquidity in a lightning channel, you will have to shut that lightning channel and start up another lightning channel. Okay, but what splicing does is that it allows you to use the liquidity in a lightning channel and transfer it to like another lightning channel. And how does this happen? Like, for instance, this is the funding transaction for a lightning channel. Okay, so you use 1 Bitcoin, you send 1 Bitcoin to a 2 of 2 multi-sig funding transaction. Okay, out of which 0.5 Bitcoin will be injected as liquidity to the lightning channel, and 0.5 Bitcoin is the change wherever it goes, comes back to the sender. Okay, so now 0.5 BTC, for instance, is not sufficient for you. You want to increase the liquidity of the lightning channel to, let's say, 1 Bitcoin. So the only option for you other than splicing is to shut this channel. Okay, and mutually close this channel and then set up another channel, which is like very, very tedious and cumbersome. What splicing does is that it allows you to use the first funding transaction, okay, and transfer the liquidity of the first funding transaction into the next funding transaction. So we take this 0.5 Bitcoin, okay, and we create a new transaction now, for instance, which has 4 inputs, as you can see: 0.5 BTC, which is from the 2 of 2 multisig account, okay, and then 0.3 BTC, let's say from Alice; 0.3 BTC, let's say from Bob; 0.5 BTC, let's say from Charlie. Okay, and then we have 3 outputs, 4 inputs and 3 outputs. 1 BTC goes to 2 of 2 multisig account. 0.1 BTC goes as change to Bob, and 0.5 BTC goes to another wallet of Charlie. So that's 0.5 plus 0.3, 0.8 plus 0.3, 1.1 plus 0.5, 1.6. And here again we have 1 plus 0.1, 1.1 plus 0.5, 1.6. Okay. So now what we have done is, without having to create like shut this funding transaction or shut this lightning channel and open another lightning channel, he just added more funds to this lightning channel. Okay, so before splicing, the liquidity was 0.5 BTC, and after splicing, the liquidity is 1 BTC. So that's what splicing does. It allows you to transfer funds from an on-chain output into a payment channel. Now, what is swapping?
One point isn't. I think this is also because Alice, Bob, and Charlie can now serve as service providers for splicing. Is it enabling that?
I mean, it need not be Alice, Bob, or Charlie. It can be anyone. I mean, you basically need more inputs, right? You have 0.5 BTC and you want 1 BTC. So where you get that money from is absolutely irrelevant. Whether Bob
Right.
gives
No,
it, Alice gives it, Charlie gives it. Yeah.
I think I framed the question a better way. So, for example, we have a lightning channel, you and I, and now we want to not close the channel, but we want to increase the liquidity. Us creating this new transaction on chain does not make sense, because it's the same as closing the channel and starting a new lightning channel. Correct me if I'm wrong. But I think because Alice, Bob, and Charlie are willing to lend us liquidity, or we can buy it from them, then it allows us to not use our other funds to increase the liquidity.
Yeah. Now I got what you're trying to say. Yeah, exactly. True.
Right.
Right. So it serves both the purpose. Like, yeah, you might even pay somebody. I don't know if this is happening right now, but you might even pay Charlie, because Charlie 0.5 BTC, and again he gets 0.5 BTC. So Charlie's transaction is basically a dummy transaction. He's just probably adding liquidity or something. So yeah, that might be the case, that somebody is just adding liquidity. You might even pay them for that. Yeah. Now you got it. Okay, so what is a swap-in? Okay, now swap root is the protocol that Phoenix calls it. A swap-in is an on-chain transaction that can be used to add funds to a lightning channel. It previously used a pay-to-script construction, that is user key plus server key, or user key plus delay. Here user is a Phoenix user and server is the async node. So like I said, this swap-in or swap root protocol existed earlier as well. But what was the difference? Earlier, what was happening is that they were using pay-to-script construction. Okay, pay to script construction. So like the 2 of 2 multi-sig transaction that we are talking about here, right? It has two users. Two users have the key, right? And they have to mutually agree to spend this transaction. So earlier, the first key was with the user, that is the user of the wallet, and the second was at the server of async, async being the pairing company of Phoenix wallet, all right? So it was a two of two account between the user of the client and the people who like run the client, the parent company, okay? So there were two mechanisms. Either both of them mutually spend the transaction, or if async goes missing for a certain amount of time, then user can single-handedly redeem their funds, okay? So user can wait for the server key to facilitate a mutual close for some amount of time, but if the server key is or async goes missing, then the user has a right to get their funds back from the 2 of 2 multisig. So this was done using pay to script. Now, the drawback of pay to script are like two drawbacks that I can think of is, firstly, it's easily detectable from the blockchain. Okay, if it's a pay to script transaction, you can look at it and make out that it's a pay to script transaction. And the second is that pay to script transactions are voluminous, okay? Because in a script, if you have 2, 3, 5, 10 conditional statements, you are eventually going to execute only one conditional statement, right? But still your script would have 10 conditional statements. Like for instance, here we have two conditions, right? But we are only going to use one. We're never going to use both the conditions, but despite that, both the conditions have to be stipulated in your script, okay? And when you're trying to spend this output, you will have to furnish the redeem script, which will have both the conditions, even if you're using only one condition. There can be 10 conditions. Eventually, you're only going to execute one condition, but those other 9 conditions will just make your script more voluminous. And when you are redeeming the transactions, you will have to furnish that script, okay? Which kind of add up on the fee that you're paying to redeem those outputs, because the script is bigger, so the size is big, and the more you end up paying. Okay, so this was the drawback of the earlier swap root protocol. Okay, so pay to script transactions are expensive, and pay to script transactions are easily detected on the blockchain, compromising privacy. Now, what they have done is that firstly, it's compatible with Taproot. Okay, so you can use P2TR transactions for funding a lightning channel. Okay, to the best of my knowledge, there are very few popular clients that have enabled this. Phoenix is the only one that comes to my mind that is like a popular lightning channel wallet that allows now P2TR transactions to inject liquidity into a lightning channel. Okay, so the benefit of P2TR is that, as you all know, you can spend the P2TR transactions using two ways. The first is the key path, and the second is the script path. Okay, and if you use the key path on the blockchain, it just looks like any other P2PKH transaction, right? Because you use this concept of aggregating public keys, okay? So if two users are spending a transaction, users are spending a transaction using the key path spend in a Taproot transaction, you will only use one public key. You will not use 3 public keys or 5 public keys or 4 public keys, right? Because all those public keys of individual users get aggregated into an aggregated public key, and their digital signatures also get aggregated into a digital signature. So the person who is trying to analyze the blockchain will see just one public key, and they cannot distinguish between this aggregated public key and the regular public key, and they cannot distinguish between this aggregated digital signature and the other digital signature. There are multiple mechanisms that you can deploy to aggregate public keys and digital signatures, whether it's using the ECDSA mechanism, or the more optimized one is Music 1 or Music 2. And I think Phoenix uses Music 2 to aggregate public keys. So what this does is, firstly, now you don't have to furnish the entire script. If you use spending using the script path, you only have to furnish the script that you are spending and the Merkle proof. You don't have to spend all the scripts, right? In a bare P2 SH transaction, what you have to do is you have to furnish the entire script. You can't only furnish the path that you are using, the clause that you're using to redeem the funds. You have to furnish the entire script, base script. But in P2TR, what you have to do is, if you're spending using the script path, you only furnish the script that you are executing and a Merkle proof to prove that this script is a valid script. That is it. And if you're using the key path, then you only furnish one public key, which is the aggregated public key, and one digital signature. Now, what this does is that this enhances privacy, because you don't have to share all the permutations or all the scripts or all the leaves in a Taproot transaction. You only have to share the clause that is getting executed, and the other clauses get hidden. Whereas that is not the case in a pay to script transaction. All the clauses get revealed to whoever is spying on the blockchain. And also, if you are using the key path, then there's only one public key on the blockchain, so nobody can figure out whether 2 people are redeeming these funds, or 3 or 5 or 10. It just looks like one public key. So this is what they've done basically. They have deployed the splicing mechanism, which they call swap root protocol, and now it enables you to inject liquidity in a Lightning channel via P2TR transactions, which enhances user privacy and also makes it more economical for you to spend these transactions. Yeah, any questions about this? I hope the broader like picture was conveyed what's being done. Okay, so it's basically a mechanism of splicing that uses P2TR as the funding transaction.
Right, and that's the essence of swap root protocol, right? Or is there anything else that we might find important?
No, to the best of my understanding, it's just a mechanism of splicing
Right.
where the funding transaction is P2TR. Okay, and what it does is that now you don't have to furnish bare scripts. You can only furnish the script that particular condition or particular leaf or node that is getting executed and the Merkle proof. So all your permutations or all your mechanisms of spending the transaction are not revealed on the blockchain. And if you're spending it using a public key, then anybody spying on the public key just sees that as one public key and cannot figure out whether 2, 3, 5, 10 people have come together to aggregate that public key. So they don't know how many people are actually spending that transaction. It just looks like there's one public key.
Right.
Cool. Okay. The next one is BitKey hardware signing device released. The BitKey device is designed to be used in a 2 of 3 multi-sig setup with a mobile device and a BitKey server key. Source code for the firmware and various components are available under a Commons Clause modified MIT license. And if anybody has been active on social media, then I'm sure your timeline is flooded with images of people buying BitKey and how gorgeous it looks. Okay. So yeah, it's I think the parent company is a Block headed by Jack Dorsey. They've come up with this 2 of 3 signing device where 2 keys are held by the user. The first key is in the mobile client in your mobile phone. The second key is in your hardware wallet. The third key is at the server of the wallet service provider. So if you want to spend a small amount of transactions, you can set a limit, like for instance, $100, $200, whatever. So that limit you can spend directly from your wallet. But if you want to spend above that limit, then you need the hardware wallet as well to sign it. And if, for instance, your hardware wallet gets lost, you still have 2 keys, one in your custody and one in the service provider's custody. Or if your phone gets lost or whatever, somebody hacks into your phone, then again they can only compromise 1 key and the 2 keys are still safe and secure. So that is what it is, and it is like a trade-off, I feel, between privacy and security. It gives a little bit of both for people who are not very tech savvy, and I think these are the kind of wallets that can help Bitcoin's adoption go mainstream. I personally have always been of the opinion, I've stated this as well, that I don't feel something like a seed signer or a cold card will take Bitcoin mainstream anytime soon. Although they're amazing for cypherpunks, for tech nerds, but for the mainstream people who are getting into Bitcoin, people who are not that tech savvy, people who cannot handle complicated devices, I think something like BitKey is a very ideal solution to orange pill people. Any comments?
I just had one question. So if you lose your mobile device, you still need to keep a backup. Is it of that key, or are you protected?
The mobile key, there is an encrypted backup kept in Google Drive or Apple Drive, as far as I know.
And who holds the decryption key? Is it the BitKey server, or do you have to manage it?
Wait. I'm not sure of this. I think the decryption key is. I think it's kept in. No, I'm not sure about this.
Right, I've heard a lot of great things about BitKey myself. Just adding one point that I think even for somebody like me, I think BitKey does serve a good purpose for keeping funds that I want to spend in a shorter term basis. So I know it compromises privacy, but I think the ease of also using a hardware device without needing to always without having a single key setup where I have a single point of failure. But what my concern was that if I lose my mobile device, then do I lose access to, the key, or do I have the option to back up?
Google Drive data's decryption key, I'm assuming that it will be held by BitKey, because they cannot access the Google Drive, right? We can forget password. Even if we lose access to Google, we can do a forget password, get the encrypted file, and then ask for the decrypting key from BitKey.
Okay, right. Okay. So yeah, so even if you lose your mobile phone, you can restore it.
Thing. Okay, it's a 2FA kind of thing. What? Sorry. Yeah. Yeah,
Oh,
sure.
sorry, sorry. Yeah, no, I was just saying one thing that even if you lose your mobile device, I think you can restore the mobile key on a separate mobile phone.
Yes.
Hmm. Nice.
But just on the downside, they will. I mean, Bitkey will know your balance.
I mean, yeah, it's not your cold storage wallet. It can be your handy that you need to spend in the next 1 year, maybe.
It can be a cold storage wallet for the normie or the non-tech savvy, like Faisal said, right?
Right, right. Yep.
So like break. You don't have to.
Faisal, you're not audible.
Right now, most people, it's better than key.
Is there some issue with
Because
Faisal's connection,
people,
or is
when you
it
find
me?
a Bitsigner on a Mark 4 on that.
We lost you for a bit, Faisal. Even
Yeah,
now,
I think Fazil's voice is breaking.
Now I'm audible, right?
yes.
Okay, yeah. Cool. Sorry. Yeah. So what I was saying is that I mean, it gets rid of firstly that mnemonic seed, which is pretty intimidating for beginners. Honestly speaking, I mean, no matter how smart you are, you're always susceptible to losing that mnemonic seed. So yeah, I feel it's like I won't recommend anybody who's here to use this, but yeah, if you want to orange pill your parents, your cousins, people who are not very tech savvy, then this could be an ideal wallet that gives a little bit of both the worlds.
Just to play devil's advocate here, I wonder how the entropy is created for this multi-sig, and if it's in mobile generated, or if it's mobile generated, does the Bitkeys app generate it? And what about the hardware? And what about their key? Their key, of course, they will be generating the entropy, but I wonder how the entropy is created here.
Right. I think it could be both,
I
right? So it could be from the device, from the hardware device, and from your mobile for the separate keys, I would imagine.
Yeah, but then you're trusting Bitkey's hardware to create, not backdoor it with any pre-derived entropy.
I mean, you do that with Jade and
Just
Cold Card as
every
well,
wallet
right?
provider. Yeah, exactly. You do that with
Exactly.
every wallet provider, right? Even if you're using a cold card Mark 4, you have no option, right? I mean, they are the ones
Right.
who give you those 12 words or 24 words. You can't choose those words.
Yep.
You can, I mean, as far as I know, I mean, you can.
I mean, with Cold Card, you can use dice rolls. So there is one option. I mean, Cold
Right.
Card has that feature.
Yes. Does
Right.
I
Jade?
don't know why, but I've always heard that software random number generators or software mnemonic seed generators are much more safer than using these mechanicals and manual ways of flipping a coin or rolling a dice.
Hmm.
I've heard this at a lot of people, and a lot of experts in cryptography say that you should never flip coins and you should
Hmm.
never roll dice. Always rely on softwares. As long as that software doesn't have a backdoor, it's tried and tested. It's a standard software used by everybody in the cryptography world. Always rely on softwares.
Yeah.
I agree. I've heard the same, but I've always been curious that why is flipping coins? So GG is a proponent of doing that, of possibly generating a private key by doing that. But I've heard that it's not a safe practice.
Yeah.
Yeah.
I mean,
Welcome to
humans can
Bitcoin,
never
where
create.
everything has two opinions.
Yeah, humans can never create the high entropy, no matter how random we think we are. But again, let's think about it. So, if the hardware is specifically built for Bitcoin, let's say Cold Card or Jade or whatever, or Bitkey, then it's there is a likeliness that it is honeypotted, right? It's possible that they could be just waiting and then sweep out some one fine day. Compared to a general purpose computer, general purpose, for example, I think it's Seed Signer, uh, with a general purpose do it yourself hardware
Wait,
wallet.
did I get you clearly? Are you saying that Jack Dorsey might be planning a full 10 years
Not
later?
him, not him. We don't know, right? Jack Dorsey.
No, yeah, right.
We know
That's
what
a good
happened
point.
when he was the CEO.
Yeah. So I think Bitkey does
I
need to
mean,
be open
point being,
source.
there is trust. Like nobody's denying Bitkey has. You have to trust people with Bitkey. If you're not okay with that, Bitkey is not with you. Well, not for you. Sorry, you have to trust this. And even they are not denying it, right? But you have to trust them. If you trust them, you use them.
I mean, the PRNG algorithm needs to be open source for any hardware wallet. So I know that Coldcard does not open source its firmware software. I think so does Jade. I don't think any hardware wallet open sources their firmware software. So there is an element of trust with all of these, except for Seed Signer.
I think they read only. They read. I mean, you can see the source code, but they won't let you contribute to it. It's theirs. It's out there in public. Go and read line by line, but they won't let you contribute to it.
Is Jade not MIT?
I'm not sure.
Neither am I. Okay. All right. Cool. So yeah, we'll move on. We've already reached 9, so we'll try and cover as much as we can in the next 15 minutes. All right. The next one is Envoy version 1.6.0 release. The release adds features for fee bumping transactions as well as canceling transactions, both enabled using replace by fee. Okay, so Envoy is a wallet. Okay, I think I'm not sure. I think this client is also developed by the parent company of Passport, the Passport hardware signing device. I'm not really sure. But the release adds features for fee bumping transactions as well as canceling transactions, both enabled using replace by fee. So their wallet now has RBF functionality where you can bump the fee of the transactions, and canceling transactions here refers to sending the transaction back to its own, like the person who initiated the transaction. If the transaction is unconfirmed, you send the transaction back to that person. This is what canceling refers to here. Okay. VLS version 0.11.0 release. The beta release allows multiple signing devices for the same Lightning node, a feature they call tag team signing. Okay. So basically what this is, wait a minute, let's go. Okay. So basically what this VLS does is it's a mechanism that separates the signer from the lightning node. Okay, generally what happens is monolithic node. Okay, this is a monolithic node, like a regular node. Where what happens is that the node itself has the authority to sign. Okay, so all incoming and outgoing transactions are authenticated by the node itself. Okay, the node has the authority to authenticate transactions. So if your node gets compromises, your your private keys also get compromised, like your signing authority also gets compromised. So all the attacker has to do is attack your node, and once the attacker attacks your node and gets into your node, the attacker gets the authority to sign transactions, to authenticate the transactions or the information that you are transmitting on the lightning network. What VLS does is that it separates the signer from the node. So your node will no longer sign the outgoing messages, meaning if your node initiates a transaction, your node will not authenticate it. The signer will be segregated from the node. Okay, the signer could be a web client, it could be a mobile client, it could be a client on a hardware device. Okay, so what happened is that even if the attacker attacks your node, the attacker will not get the authority to sign transactions, because the signer of your node has now been separated from your node. Okay, so the attacker will have to attack that signer. Okay, and the surface area of attacking that signer is difficult. I mean, attacking a node is relatively easier as compared to attacking a segregated signer. So this is what it does. What VLS does is that it pulls out the signing authority for initiating transactions from your node and gives it to a segregated attacker, which is separate and secluded from your node. Could be a web client, could be a mobile client, or could be a client on a hardware device. That is what VLS does, and that's what they call tag team signing. You can even have multiple signers, basically 2 signers, 3 signers, 4 signers. You can have multiple signers. So even if a node gets compromised, the signer is not compromised. Nobody can initiate transactions from your node and authenticate them. That is what this is about. The next one is Portal hardware signing device announced. They recently announced Portal device works with smartphones using NFC with hardware and software source available. What is Portal? Let me see. I think it's that new device, is it?
Yeah,
It looks like a key.
Yes.
Yeah, I think, yeah. So it's a new signing device, something more to play with the gadget savvy people. Up till now we had like I think there's a SATS card.
Tap signer
SATS
and
card
SAT
that you
card.
can, yeah, and now you also have this thing, but they don't. what do you say? A SATS card doesn't have a mnemonic seed or anything like that. Okay, but
Yes.
uh, what is the second thing you said, Shian? I'm not able to
Tap
recall.
signer.
SATS card and
Tap
tap signer.
signer.
Tap signer has a mnemonic seed, right?
I don't think so. You can't generate no, you can't generate a wallet. You can only sign transactions. So
Okay, got it. I think this also might be similar. Then you just put it on the back of your wallet.
right. I think the new feature with this is that it has a screen, so you can also use
Yeah,
it as a new wallet.
right. That is what I was. You can continuously use it, right? Like I mean, SATS card is something that is not like reusable. You once you sweep the slot, it just goes away.
Hmm.
Okay, yeah.
I haven't used any
I
of them.
think
Have you used any of them? Tap signer or Sat card?
I've used SATS card just to play with it. It's not something that I would recommend anybody. But if you are into gadgets, if you love exploring different devices for educational purpose, you can do it. So I just for the sake of playing with it, I got a SATS
Right.
card and
It
just
looks like a credit
nominal
card,
amount
right?
of funds.
Like a
Yeah, just
really
a
simple.
credit card.
Hmm.
Yeah,
Nice.
and you can get it in multiple skins. Don't ever get one that has Bitcoin on the skin.
Yeah.
Just like a out of band advice. Cool. Brains mining pool adds a Lightning support. The Brains mining pool announced a beta for mining payouts through Lightning. We're over time, so like people who are not very regular with this session, we generally extend it a little bit. Okay, we tell you 8 to 9, but we make you stay till 9:50, 9:20, even 9:30. Please bear with us. Me, Stan, and Mango generally we stay back till 9:30. Brains mining pool adds Lightning support. The Brains mining pool announced a beta for mining payouts through Lightning. This is great, I feel. Brains is one of the first mining pools that officially announced support to Stratum V2. Stratum is basically a software protocol that enables communication between solo miners and the nodes. And what Stratum V2 does is that it allows the solo miners to choose the templates, to choose the block template. So it gives the authority from the mining pool, transfers the authority from the mining pool to the solo miners to choose block templates. That's what Stratum V2 does. And Brains mining pool, I think, is one
Not
of the
just
first mining
that.
pools that announced.
Stratum V2 doesn't just do that. It also does V2, like encryption thing for miners. Because now it's all in
Oh,
plain text. So it's extending the 324 stuff to miners too.
okay, so two features we know about, right? Firstly, the miners can now, what do you say? The miners can now determine the template and also the information that is being transmitted between the solo miners and the mining pool operators is over, like it's encrypted, right?
Yeah, it's encrypted in Stratum.
Wait, Shatafa, what's the advantage of that? Why is a mining pool
Sorry, someone rang the bell. You can
okay?
continue.
So I'll ask this to rest of the people that do you think what's the reason that you would need privacy from the coordinator as a mining pool
I mean, I
node?
can come up with a generic answer. Privacy is always good, right? If I'm communicating with anybody on the internet, only that relevant person needs to know that information. Why should like
No,
anybody else have access to that information?
but you understand that the mining pool is only creating block template and block hashes, right? So, I mean, is it sensitive information that they anyway need to share this with the coordinator?
Which coordinate? This information only has to be between the solo miners and the mining pool, right?
Yes,
So it's
exactly.
possible. It's possible that somebody could detect what
Okay, somebody can
transactions
eavesdrop.
are
Yes.
included.
Oh, right.
Yeah,
Yes,
and
makes
then
sense. Right.
force the
I
mining pool
think,
not to censor some transactions or something.
right. Agreed. Yes, yes.
Uh,
I think even you can participate in a mining pool even being in India. So it's not as if you have to actually physically have a mining pool in the mining farm. So yeah, the privacy feature is a great add-on.
Yes, if you want to lose money, do that in India.
No, dude. So people are doing it. So I will not dox it, but you can actually participate in mining pools, and it's a very sophisticated market. So you can switch between mining pools within milliseconds. It's like you can create a bot, and whichever mining pool is increasing hash rate or has better reputation, better bandwidth, you can switch between them as well.
Yeah, but I mean, electricity is so expensive in India. It's a luxury. I don't
No,
know. I mean, like somebody. I mean, I'm talking about somebody like sitting in their house, like somebody like you and me. I'm not talking somebody who sets up a plant or something or gets cheap electricity that is surplus through a government or something like that. I'm talking about like Bitcoin enthusiasts like you and me. Like we run our nodes. Like we have our hardware wallets. Somebody who's just enthusiastic about Bitcoin decides to buy an ASIC and put it in their house and use domestic electricity. I think that could be suicide. I don't. Right? Especially if you're living on a rent, your landlord is going to throw you out for the electric bill.
Right. Yeah, I don't know how he is doing it, but yeah, so he's also sourcing miners. So last time we spoke about how it's a challenge on custom, but I think he has figured it out. So if somebody's interested to try it out, let me know.
Cool. Now let's wrap it up in less than 5 to 6 minutes maximum. Okay.
Just a
After that,
link.
we can. I suggest that we'll just wrap it up in 5 minutes. Okay. After that, we can tell Jatin to stop recording, and then we can stay back to talk for as long as we want to. What's it? Okay.
Yeah. Yeah, Faisal, just
Yeah.
just
So
lingual correction. Like solo miners are people who mine on their own without a pool. I think linguistically, I think a better word is hashers and mining pool. Hashers are people who are only hashing, working under a pool,
Makes
and
sense.
solo miners are people who working independently.
okay, I thought I'm the only grammar Nazi. Cool.
No, I got
You were so curious, despite the fact that I repeatedly kept on saying that we will not stop the session now for any interruptions. You interrupted. That goes on to show the the style, the level at which you're a grammar Nazi. Even I'm like that. If I come across a grammatical error, I just feel so uneasy until and unless I don't interrupt and correct that person.
because yeah, I mean,
It's an
each time
itch.
you said that, I was trying to imagine solo miner. Okay, how is solo miner doing this?
Yes, it's an itch that a lot of people have. Cool. Okay. So Ledger Bitcoin app 2.2 release 2.2.0 release, the 2.2.0 release adds Miniscript support for Taproot. So this is pretty self-evident. Like the Ledger wallet now adds support for Miniscript and for Taproot. Release and release candidates. Bitcoin Core 26.1 RC2 is a release candidate for a maintenance release of the network's predominant full node implementation. And Bitcoin Core 27.0 RC is a release candidate for the next major version of the network's predominant full node implementation. Okay, cool. Notable code and documentation changes. Okay, we'll go through this quickly, just read it. I think I have it in my notes if somebody would like to go through it. Bitcoin PR number 27375 adds support to the proxy and onion features for using Unix domain sockets rather than local TCP ports. Sockets can be faster than TCP ports and offer different security trade-offs. So basically, if there are multiple processes running on your local computer on which you're running a Bitcoin node, you can also use the feature of Tor and a proxy server to enable communication between internal processes that are running on your computer. I have it in my notes. I'll just quickly show where it is. Yeah, basically, okay. Yeah, this is how it generally happens. So there's one laptop. There are two processes running in that one same laptop. This one, yeah, okay. So now even two processes that are running on the same laptop can use onion encryption to communicate with each other, and that basically enhances user privacy. And you can also set up a proxy server that acts as an intermediary to communicate information between two processes that are on the same system or the same laptop. That is what it does. Bitcoin Core PR number 27114 allows adding in and out to the whitelist configuration parameter to give special access to particular incoming and outgoing connections. By default, a peer listed in the whitelist will only receive special access when it connects to the user's local node. An incoming connection, by specifying out, the user can now ensure a peer receives special access if the local node connects to it, such as by the user calling the add node RPC. So we had an entire PR review session moderated by Statusfer, in which we discussed this. It was possible for you to whitelist incoming connections or inbound peers. Now you can also whitelist outbound peers and give them some special privileges like no ban, etc., etc. Whoever would like to delve into more detail can go and check out that video if it's available. I think it surely must be on Bitshala's Twitter timeline, even if it's not on YouTube. It's not on YouTube for sure right now, but
We didn't
maybe it's on
record this for the
Bitshala's Twitter
first time
timeline.
they record. The first recording is
So we didn't record it.
the first time we did it, it recorded.
Yeah. Yes.
Yeah,
That's
we have to
the
remove in and out. Like, I'm getting so annoyed. In and out, like we're going to remove that for the next.
I didn't get you. Can you come up again?
Oh, like we discussed in the PR review club, like in and out doesn't really make sense.
Okay.
So yeah, I want to remove those flags.
So like if you're whitelisting, you whitelist both of them, and if you're not whitelisting, you don't whitelist any of them.
Yeah, there is a node. It doesn't matter if it's inbound or out or a manual. Like if you specify, if you say you're whitelisting a peer, like there's no use case where you, like I cannot think of a use case where you would want to give separate permissions to the same peer depending on whether that peer opens the connection or whether you open the connection.
Right, cool. Yeah, as we discussed, because once the connection is established, both the nodes basically do the same thing.
Yeah. So that's something I'm interested in exploring.
Sure. Cool. Bitcoin code PR number 29306 adds sibling eviction for transactions descended from an unconfirmed V3 parent. This can provide a satisfactory alternative to CP/FP carve-out, which is currently used by LN anchor outputs. V3 transaction relay, including sibling eviction, is not currently enabled for mainnet. So yeah, we covered this in detail. This is proposed by Gloria Zhao, and I think we have covered it in one of the preceding Optech sessions. I can't remember 285 or 286, but we discussed in detail about what CPFP carve-out is, what V3 parent is, what anchor outputs are, what sibling eviction is. We discussed this in a lot of detail. You can also refer to the article that is in one of the newsletters, and also the podcast that took place, the recap. And also, I'm not sure if this video that we did is uploaded, but it'll soon get uploaded. So yeah, you can refer back to that content that is available, and you'll find it on Bitshala's Twitter timeline as well, where we discussed it, sibling eviction. LND PR number 8310 allows RPC user and RPC password configuration parameters to be retrieved from the system environment. This can allow, for example, nd.conf file to be managed using a non-private revision control system without storing the private username and password. So we have this LND conf file, just like we have a Bitcoin conf file in which you have the RPC username and password written in plain text. Instead of doing that, this PR proposes or allows the users to retrieve their username and password from the system environment. So if somebody gets access to your lnd.conf file, your username and password is not written in plain text, rather it is deduced or retrieved from the system environment. Rust Bitcoin PR number 2458 adds support for signing PSBTs that include taproot inputs. This is pretty self-explanatory. Yeah. So we've come to the end of the session. Okay. Any closing notes that are strictly, related to the Optech newsletter? If you want to talk about something other than the Optech newsletter, then we'll all stay back, or whoever wants to stay back can stay back. But anything specific regarding to the newsletter? Closing comments or anything?
I think Stratum, you mentioned the encryption that comes with Stratum V2. Is it the same as encrypting all the messages between the hashers and the coordinator? Or is there any other privacy feature that comes with it?
You mean algorithmically? Like we're still using Charts20 Poly1305, but some ciphers, but the underlying cryptography is same, but
not even algorithm. I think the messages. Is it just the identity? Because why I asked this is because I was curious that is it the block templates and the block hash that they also encrypt? Because I don't know if that's sensitive information or if it is. I might be wrong. So
it is like if. Oh yeah, I think that uses a different protocol. First of all, not the Bitcoin protocol communicate.
Right.
It's a separate protocol using which we communicate between the pools and all that. And also it's sensitive because if it's over the internet and it's clear text, again the eavesdropping passive things can be done by ISPs, governments, anyone, right?
Right.
So it's kind of like targeting who all are mining in.
Right. So it does not use the Bitcoin P2P layer, right? I think it uses something called. I think we discussed this in one of the cohorts. I think there's a block relay network for miners to communicate.
A fiber.
Maybe I'm not able to recall the name.
Fiber is not used
fiber.
anymore. It's not used anymore. Like that.
Okay.
I saw the repository is replicated.
Okay. Thanks.